In this video, we're going to learn about plane tracking in visionOS, and we'll do this by creating this simple sphere that we'll place on a table, and it will be tracked and locked there. So let's build this and learn about plane tracking in visionOS.
So I'm going to open up Xcode, create a new project, and make sure you select the visionOS option to create a visionOS app, and then click App, and click Next. Name this whatever you want. I'm going to name this project Vision Basics Plane Detection. Make sure the initial scene to window and immersive space render is set to none. Hit Next and save it wherever you want. Click Create, and then you should have your project ready. Great, so this is some default code that comes with visionOS, essentially a window showing a sphere and a text below that. I'm going to get rid of that because we're not going to use that. And I'm going to close the previews as well, mainly because in this example, we're trying to detect a plane in the real world, namely a table. Plane tracking or any kind of ARKit based tracking cannot work in a simulator. You need a real device for this. So I'm going to get rid of the canvas. And here, what I'm going to do is inside the body, just to silence the error, I'm going to create an empty view for now. I'm also going to get rid of this preview guy here because we don't need that. So in this example, what we need to do is first we need to detect a table or a horizontal plane, and then we need to place a sphere there, right? So first let's create that sphere that we need to place. Whenever you create a 3D scene using RealityKit, everything is an entity, including visible things like 3D models and invisible things like audio sources. So in this case, we want to create a visible entity, which is a sphere, right? So we're going to create a new sphere entity, a computed property, and this should return a model entity. Again, a model entity is the kind of entity that has visuals like a mesh and a material. So here for the sphere mesh resource.generate, and you can generate different primitives here. And I'm going to say generate sphere. And I'm going to give it a radius of 0.05. Then I'm going to create a material. Let's make this a simple material. Let's give it a color of say yellow, and it's metallic. Let's set it to false. We don't want that metallic look. Now with the mesh and material, we can create a model entity. So for that, I'm going to say let sphere entity equals model entity. This creates a model with a particular mesh and a set of materials. We'll just pass in the mesh that we just created. And for the materials, we'll just pass in the material that we had. Awesome. So now we got a mesh material and we created a model entity out of that mesh and material. Now we simply return that model entity. So great. So now we got the 3D model ready. Now we need to display it on the table, right? And anchor it there. So anytime you want to display 3D content, you need to use a reality view. A reality view is a SwiftUI view that lets you display 3D scenes as complex as you want. So here I'm going to replace the empty view with a reality view, and the reality view comes with this content guy here. And this content essentially contains all the entities, visible and invisible, in the scene. And at the moment, there's nothing in that content, nothing in the 3D scene. So to add the sphere to the 3D scene, what we can do is simply content.add and sphere. Great, so this will simply add the sphere in the 3D view. But that's not really what we want here, right? We want to anchor the sphere onto the table. So to do that, what we can do is first, we can create an anchor entity to detect a plane. So what we can do is anchor, and let's say anchor entity. And you can see there's an option with a plane and a classification. So for the plane, I can select horizontal or vertical. What this would do is when the app first starts and the reality view is displayed, ARKit under the hood would look for any horizontal surfaces in the user's surroundings. And if it has found any, it would place an anchor there. And an anchor, you can think of it like a lock, right? Once it's there, it cannot be moved, regardless of the user's movement. So if you imagine the table, ARKit places an anchor there, and then on top of the anchor, we could place the sphere. That way, when the user moves around, the sphere would remain anchored or locked to the table. That's how we create augmented reality experiences, by creating various anchors and anchoring objects in the user's surroundings so that it stays fixed and locked there as if it's part of the real world. Great. So here, let's choose horizontal because we want to detect only horizontal planes in the user surrounding. And also we're going to narrow it down a bit more by choosing this classification guy here. And here you can see various options. You can anchor it to the ceiling, floor, table, wall. I'm going to choose table. So this bit of code, all it would do is it would create an anchor entity that looks for any tables in the user surroundings. And once it's found something that looks like a table in the user surroundings, it would essentially place an anchor there to which we can attach objects and lock things there as if it's part of the real world. An anchor entity by itself is just invisible, right? There's nothing there. We want to attach the sphere to that anchor. We can just do anchor.add child and then add the sphere, i.e. this model entity that we have here, as a child of that anchor. This way the sphere gets attached to that anchor and stays locked in wherever that anchor is placed. Great, so now we got the anchor entity containing the sphere, and now we can simply add that anchor to the scene. Content add and anchor. Great, simple as that. We created an anchor entity that creates a hook and a lock wherever ARKit finds a table, and then we simply attach the sphere to that anchor so it stays locked with that anchor. That's all you got to do. Awesome, so that's the 3D scene bit done. Now before we build and play, we need to do one more thing, right? So any kind of ARKit based tracking, whether you're tracking the user's hand, the table, the walls, any kind of ARKit based tracking requires the visionOS experience to be running in immersive spaces. If you're not familiar with what immersive spaces are, in visionOS there are two kinds of spaces, shared space and immersive space. Shared space is where your app coexists with other apps, and that's where you can display like windows and volumes only. And an immersive space is where your app cannot coexist with other apps. It's just your app. And within immersive spaces, there's progressive space, full space, and mixed space. And ARKit based tracking can only work in the mixed space. Again, if you're not familiar with what immersive spaces are, I've got other videos going over that. So just check that out. For this particular use case, just remember, ARKit based tracking will only work with mixed immersive spaces. So to fix that, what we need to do is go to the starting point of the app, the file named after your project name, in this case, this guy here, and it will be marked with this main guy here. This is the starting point and the entry point for your app. And here you can say we're displaying a window, right? Instead of a window, what we want is an immersive space, and more specifically, the mixed space. So I'm just going to quickly do that. Immersive space, and then we can set the immersion style. So I'm going to create a new state var and call this immersion style. And this would be of type immersion style. And we want the mixed immersive space. Again, immersive space has full, mixed, and progressive modes. And what we want is mixed immersive space because that's what gives us the pass-through content, right? The camera feed. And the ARKit based tracking requires the camera feed to see the user's real world. So we want the mixed space, and then we're going to set the selection to that state variable here. So immersion style. So we're simply binding the state variable to the selection here. And for the options, we're going to choose, say, mixed, full, and progressive. Awesome. So here, instead of showing a window, now we show an immersive space, which displays the content view containing the reality view that we just designed earlier. Awesome. Now, before we run this app, we need to do one final thing. Go to info plist, and here in the application scene manifest, you can see the preferred default scene session role. This tells visionOS what the first scene is expected to be in your app. And before it was the window, but now it's an immersive space, right? So now we need to change from window here to immersive space application session role. This will tell visionOS, hey, when the app first starts, we're showing an immersive space. Great. And now let's try running this app and see what we get.
Awesome. So now you can see the plane tracking is working, right? So the sphere is placed on the table and it's tracked there. There's an anchor entity that's tracking the sphere. Awesome. So that's it for this video, and I'll see you soon.